Okay, good morning. Welcome to
FunMath number 37.
FunMath number 37. I'm going to try to go through this one quickly, but this might be a little bit longer than normal. A row of lockers is numbered 1 through 20. You know what lockers are?
Yeah, they're like these, they're like little cupboards where you can put stuff into.
Yep. And they're all initially closed. Step 1 is to open every locker. Step 2 is to change the state of every locker that is a multiple of 2. So in other words, if it's closed, you open it, and if you open it, and if it's open, you close it. So you know what I mean? It's either if it's closed, you open it, and if it's open, you close it. Step 3 is to do the same thing for every locker that's a multiple of 3. Step 4, every locker that's a multiple of 4, and it's going to be all the way up to step 20, where you change the state of every one that's a multiple of 20. How many are multiples of 20?
There's going to be 1 through 20.
How many are just multiples of 20?
Just one of them.
Just one of them, just 20. Okay, so we're going to use orange to be open and green to be closed. Now they all start off closed. So in step 1, what do you do?
We open every one of them.
We open every one of them. Okay, now they're all open. What do you do in step 2?
We change the state of every locker that's a multiple of 2.
Change the state of every locker that's a multiple of 2. Okay, so what does that mean you're going to do?
It means I'm going to close every one of them that's a multiple of 2.
You're going to close every one that's a multiple of 2. Okay, so put green there. Okay, now we're going to change the state of every one that's a multiple of 3. You ready?
Yep.
3, what do you do?
We're going to close this one.
Close it. 6, what do you do?
We open it.
9, what do you do?
We close it.
Close it. 12, what do you do?
We open it.
Open it. 15.
Close.
18.
Open.
And that's it, right? Those are multiples of 3, right?
Yep.
Now multiples of 4.
4, we open.
8.
We open.
12.
We close.
16.
We open.
Open. 20.
We close. No, wait, we open.
Open. Okay, woo! 5.
5, we close it.
10.
We open it.
15.
We're gonna open it.
20.
We close it.
6. You're going to do multiples of 6 now.
Okay, we close this.
12.
Open.
18.
We close.
Okay, multiples of 7.
Close.
14.
We open.
Okay, now we're going faster because then we only got 2. 8.
8, we're going to close.
16.
Open. No, wait, close.
Close. Turn it green. Okay. 9.
We're gonna open.
Open. 18.
We'll go, no, 18.
18, sorry.
We're gonna open.
10.
10, we're gonna close.
Close. And 20, we're gonna
Open.
open. Okay, now let's stop here for a second. And now notice when I go through 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20, there's only one
Multiple.
There's only one multiple. So all we're going to do is we're going to change all of these orange ones to green, and we're going to change the green one to orange. Right?
Yeah.
So get your green marker for 11, 12, 13, 14, and 15. Change those green. Okay, 16 we're going to change orange. And 17, 18, 19, and 20 are going to go green. Okay, now green means closed.
Yeah.
And orange means open. And initially they all started what?
Open. Well, initially they all started closed.
Initially they all started closed, so initially they would have been all green if we would have thought to color them all green in the beginning. Which ones are open after this process? Do you notice?
Well, 1, 4, 9, and 16.
Okay.
Those are perfect squares.
Ah, interesting. The perfect squares are the ones that are open. Which ones are closed?
The ones that aren't perfect squares.
The ones that aren't perfect squares. That's very interesting. Why are the ones with perfect squares open? That's the interesting question. When do you open or close a locker?
When it's a multiple of a certain number.
When you're doing a multiple of a certain number. Since they all started closed, how is a door left open?
If it's a multiple of that number.
No. At the end.
Oh.
How many times does it have to be open or closed to be left open? It can be open one time?
Yeah.
So it can be switched once, because then it would be open. If you switch it twice, is it open or closed?
It's closed.
If you switch it 3 times, is it open or closed?
It's open.
Okay, so if it's switched once, it's open. If it's switched 3 times, it's open. 3 times, it's open.
Yeah.
If it's switched 5 times, it's open. 7 times, it's open.
9 times.
What's the pattern?
Odd numbers.
Odd numbers of switching leave it open, and even number of switching leave it closed. Why do the perfect squares get switched an odd number of times?
Well, perfect squares are something to an even power.
Yeah.
They have an odd number of divisors.
Ah, very interesting. Perfect squares have an odd number of divisors. Non-perfect squares have an even number of divisors. So how many times do the perfect squares get switched?
Well,
Either open or closed, open, closed, open, closed.
the number of their divisors.
Each number gets switched every time you have a divisor. So for example, 6 gets switched on turns 1, 2, 3, and 6, or 4 times, which is an even number of times. 9 gets switched on 1, 3, and 9, which is
3 times. Well, it's an odd number.
It's an odd number. So the non-perfect squares get switched an even number of times. The perfect squares get switched an odd number of times. And so what happens to the perfect squares when they're switched an odd number of times?
They're open.
They get left open. And what happens to the non-perfect squares?
They get closed.
They get closed. Okay, so now, here's a fun question for you. If instead of just doing 1 through 20, I did this on lockers numbered 1 through 100, and I did the whole process, 100 steps. Step 1, open them all. Step 2, change the state of the even ones. Step 3, change the state of the multiples of 3. Step 4, change the state of the multiples of 4, all the way up to 100. Which lockers would be open?
The perfect squares.
What are the perfect squares up to 100?
4, 9, 16, then 25, 36, 7 squares, 49, 64, 81, and 100.
And 100. There you go. So this is a really neat divisor problem. This is a sneaky divisor problem. So if I asked you to do this up to 1,000, you do it for a small number, look for the pattern, notice that the pattern is the perfect squares are always left open. The reason the perfect squares are left open is because a door gets switched every time there's a divisor. And if you start closed and you get switched an odd number of times, you end up open. So if we ever go to a place where there's 100 lockers, maybe we could do this. Or maybe just 20.
Yeah.
All right? This is a really famous problem called the locker problem. So fun. Very fun problem for kids. Very fun problem.